Hello everyone. Today we will discuss about electric dipole. Electric dipole, this is the definition. An electric dipole is a pair of equal and opposite point charges q and minus q separated by a distance 2a. So the dipole, that means we have a charge plus q minus q separated by some distance twice a. Why we take this distance as twice a? It is because if we consider the center O, this distance is a, this distance is a. Now the line joining the two charges actually represents some direction in space. This direction from negative charge to positive charge, we define a vector called dipole moment vector. This P is called dipole moment vector and it represents strength of the dipole. There's a definition of this. The definition is that magnitude of P is the product of the charge into distance between the charge. P is equal to Q 2A. Because of this, the unit SI unit is Q is measured in coulomb, distance is measured in meter, coulomb meter, and the direction from negative to positive charge. So whenever we have a charge configuration like this, we express the strength of the dipole in terms of P, dipole moment vector. So it is very important to know this definition and this direction. Now total charge of a dipole. Total charge of a dipole, as we know from the property of charges can be added. So it will be plus q minus q, which cancels and you get a 0. That means total charge of a dipole is 0. But we say charge of dipole plus minus q or simply q. Total charge is 0, but the charge is plus minus q. Actually, why, even though total charge is 0, why we are so much concerned about dipole? It is because dipoles are present in many type of molecules. Say for example, let us take the example of say HCl molecule. Here the charge center of positive charge and a negative charge, they are not symmetrical. That means they are not at the same point, because of which the total positive charge and the negative charge, they are slightly separated by distance. So it will have a dipole in it, and this give rise to interesting property of this hydrochloric acid molecules. Another example you can take is like water. Water is liquid because of the presence of permanent dipole moment in it. The meaning is that in water also the charge center of positive and negative are not at the same point. They are slightly separated, because of which we get a dipole moment in water also. And many property of water, physical property of water like liquid, is because of this intrinsic dipole moment. That means inbuilt dipole moment, because of the molecular structure. So that is why this topic electric dipole is important, and we have to know how to find electric field due to dipole, which is the next topic. We have two topics: electric field of a dipole, 4 points on the axis and 4 points on equatorial plane. Both of them are important, so let us go one by one. Electric field due to a dipole on each axis. Now what is the meaning of axis? What is the meaning of axis? This is plus positive charge, this is the negative charge. This line joining the two charges is the axis, dipole axis. So if we take any point on this line, maybe this point, maybe this point or any point on this axis is a point on the axis, and we want to find the electric field at such a point. For that, let us go according to the book. Let us follow this one. We have positive charge here, we have the negative charge here. The distance between them is 2a, and we are considering a point here, P, and this distance we are taking as R from the center. This point is the center O. So here we want to find the electric field. As we know from principle of superposition, electric field at a point due to a charge configuration is the vector sum of the electric field due to individual charges. That means total electric field here is the vector sum of the electric field due to this positive charge and electric field due to this negative charge at this point. That means like this. So we have to do this vector addition. Now how do we find electric field? Electric field, if you remember, electric field is given as force per unit charge, and the formula is 1 by 4 pi epsilon naught, the charge which is producing the field divided by distance square. This is the formula for electric field. This one we are going to apply. For this positive charge, direction of electric field will be radially outward. That means this will be the direction of the electric field due to this positive charge, and the magnitude will be 1 by 4 pi epsilon naught, the charge itself, that is plus q, and the distance, we need this distance, and this distance is, this whole thing is r, this much is a, so it means r minus a with a square. Now let us see the direction. The direction is from negative to positive charge. This is the direction, and we know that this is the direction of dipole moment vector from negative to positive charge. So we put this p cap. P cap is the unit vector of this dipole moment vector. It gives the direction of this vector. Plus, now let us see the electric field due to this negative charge. So electric field due to negative charge will be in this direction, because the direction of electric field due to negative charge is radially inward, so it will be the direction, and the magnitude will be 1 by 4 pi epsilon naught q r. Now what about the distance? We need this distance from here to here, from here to here. This much is twice, this much is two. From here to here it is r, then this is extra a, so it will be r plus a with a square, and the direction is this side, so minus p cap, like this. So let me write it in a better way. So the electric field is equal to, I can take this 1 by 4 pi epsilon naught common, because it is present in both of them, then q is also present, so let us take that also common. Then from here we have 1 by r minus a square, and from here we have 1 by r plus a square, and then this p cap. This minus sign I have absorbed it here, so I get this p cap. Then we need to just solve this. R minus a, r plus a, LCM, r plus a square, r minus a square with p cap, like this. And you apply identity that you have learned in lower classes. A plus r plus a into r minus a will give you, let me write it one more step. So I have taken the square common, and this will give me a plus b whole square minus a minus b whole square is 4a b, a plus b whole square minus a minus b whole square is 4ab. This identity I have used, and here I am going to use a plus b into a minus b p cap. So let us rewrite this like this: 2 here, q, this q here, this q here, and 2a here with a p cap, and below I write r square minus a square with a square like this. Now you can see that q into twice a p unit vector is nothing but p vector, since p vector is q into 2a with the unit vector. Already we have defined this, divided by 4 pi epsilon naught r square minus a square. So this is the total electric field due to the dipole. Now we can use as an assumption. Did we miss something? Yes, we have missed this r. This r is missed here, so let us write this r. We use a condition: if r is much larger than a, the meaning is that this is plus charge, this is minus charge, this distance is twice a. Let us say this point is very far away, so that I can use this assumption. Why this assumption is used? Because in most practical cases the distance between the two charges is much smaller compared to this distance. So this is why this condition can be applied. So in this case you will see that r square minus a square, this a is very small compared to r, so you can ignore this. So this is nearly equal to r to the power 4. So electric field will become r to the power 4 like this. This one you can cancel, and ultimately you are going to get this equation. Okay, this is a very important equation. It is very common in exam. I hope you are able to understand this. Now let us, this equation as you can see in the book is same as this one, okay, or you can see here same equation. Okay, now let us discuss 4 points on equatorial plane. Now first, what is an equatorial plane? Equatorial plane. Equatorial plane means a plane which is perpendicular and passing through center of the dipole. The meaning is, suppose I have a plus charge, I have the dipole here, this is the center of the dipole. If I imagine a plane which is passing through the center and perpendicular to the dipole axis like this, this plane is the equatorial plane. So let me draw in this figure. So this is the equatorial plane. This is the equatorial plane. So here let us consider a point here P, and I want to find the electric field due to this dipole at this point. This distance, as we already know, it is a, this is also a, and let us take this distance as r from the dipole center. You must have observed that the distances we always take from the center of the dipole. Then this distance from Pythagoras theorem will be a square plus r square, and this distance, which is also equal, will be a square plus r square. We need these distances to find the electric field. So the direction of dipole moment will be from here to here. So electric field at P, electric field at P is a vector sum of electric field due to the plus charge and the minus charge. This is according to principle of superposition, and we already know how to find electric field. 1 by 4 pi epsilon naught, the charge and the distance square. So I have to take this distance and square it, and the direction will be this side. For positive charge, this will be the direction. So let us give some name to this. Let us give this name. It will be AP, along AP, this side. And here, since it is a negative charge, direction of electric field will be this side. And the magnitude will be 1 by 4 pi epsilon naught q. Distance is a square, r square, root over is there. From the formula for electric field, we get a square, and the direction will be along PB, P to B. Okay. So the situation is like this. This is E plus Q, electric field due to positive charge. This is electric field due to the negative charge. If this angle is theta, and if we take, that means if this angle is theta, this theta, then this angle will also be theta. Now we can apply our knowledge of resolution of vector that was present in HS first year. If we resolve this vector along this direction, I get a component E plus Q cos theta and another component this side, E plus Q sin theta. If I resolve this vector in this direction, I get E minus Q cos theta and the other E minus Q sin theta. And you can see that the magnitude of E plus Q, which is this quantity, and magnitude of E minus Q, which is this quantity, they are the same. That means these two components are same, so they will cancel each other, and these two components being in the same direction will add up. Therefore total electric field will be E plus Q cos theta, E minus Q cos theta. Now we have to take the direction also. The direction is this side. The direction of P vector is this side. Now this is in opposite side, so I have to put a minus P like this. So this will be the total electric field. Now let us put the value like this. This is also, the magnitude is same, and this minus P cap, and then cos theta I take common. I have written this cos theta here. So this cos theta is here, this minus P cap is here, and then I put the magnitude, and you can clearly see this will give us 2q 4 pi epsilon naught a square plus r square. And then cos theta, we know that the ratio of cos is base by hypotenuse. So here the base is a and hypotenuse is a square plus r square. So I am going to put this value here, a square plus r square. Let us write a half. This root over I have written as half, like this. And then I can write it like this, q into twice a, this minus sign here, and p cap. There is a reason behind this, it will be clear very soon. And then 1 plus half, it will be 1 plus half. Okay, so this one, as you can see, this is the equation that we are going to get. And this one is nothing but p vector, because p vector is q into twice a with p cap. So this has been converted like this, and this one can be written like this, a square r square 3 by 2. Okay, so now we apply, this is the electric field, this is the electric field, result of electric field, this equation. Okay, r square plus a square 3 by 2. Now we apply the condition, the simplification condition, if r is very very larger than a square plus r square is nearly equal to r square only. That means this a square can be ignored. If we ignore this, a square plus r square 3 by 2 will become r square 3 by 2. This cancel and this will become r cube. Therefore electric field will be minus p vector 4 pi epsilon naught r cube only, for r much greater than a. So this is one equation for electric field on the equatorial plane, and this is the equation for electric field on the dipole axis. I hope you are able to follow whatever I was trying to convey. If you have any doubt, you can drop your doubt in the comment section below. Thank you.